All right. Good morning. So today we're going to do two things. Overall, we're going to focus on transformations in Grasshopper. So that is doing stuff like moving things, rotating things, scaling things. And we're also going to look at something called image sampling, because even though it might seem at first kind of a weird, gimmicky process wherein you use this picture of a sassy dog to make something in Grasshopper. Also, sassy dog _ square is in Dropbox. So you have this image. It can actually be used for very practical purposes like solar analyses and also facade manipulation based on said solar analyses, as well as just general form finding and form making. So we're using kind of a sassy example, but in the first half of the class. But the second half of the class, what we're going to do is we're going to use a gradient. And even though this gradient is black to white, you could imagine it is actually a map of, let's say, a radiation on a brick wall. And what we are going to do is we are going to make this brick wall here that rotates and opens up dependent on the value of the white to black grayscale. We'll also look at how to make automatic brick walls that can sort of rotate and have kind of cool stacked bricks, as well as a standard just brick wall. And then here I'm just showing how what we're going to do in class can just be applied to a whole bunch of different scenarios. One thing to note, I will save Thena's file in the Dropbox. The way I'm going to do this is a little bit different than maybe the other sections are doing it. And there's two reasons for that. One, I figured that if I give you Thena's file and then you follow along with me in class, you're able to compare two different ways of doing a very similar thing to see that there are multiple ways to do something in Grasshopper. And two, it might give you fodder for your assignment too. So try working in some of the things that are in Thena's definition into the definition we use. And I guess a third thing, it's also just a lot easier for me to kind of work through something that I've sort of done myself. So in Grasshopper, you'll find that certain people have certain ways of doing things. There's usually no one single answer. But I mean, as long as you're, I guess, organized and concise and think through what you want to do, all methods are whatever works is essentially. So that being said, for this class, the only two files you'll need is this sassy dog square and this gradient sample. You could also use another black and white image of your choosing, but these are in the Dropbox folder. So what I'm going to do is I'm just going to open a new Rhino window. So all of you can just start blank, like so. And then I am going to open Grasshopper. Yes, this is recording. Good. Now we're going to start from just a blank Grasshopper canvas. I am going to open a file just so I can make sure I stay on track. So essentially what we're going to do here, I'll sort of show you the final result. Essentially what we are going to do is we're going to take a grid, so sort of like we used last time. So we'll have this grid. We'll draw circles at every vertex of the grid. And then what we're going to do is we're going to take the this image of the sassy dog there, and we're going to say, dependent on the darkness of a sampled point, make the circle larger or smaller. So you see what happens here. It's quite abstract, and it's funny when you do this. Sometimes if you zoom out quite a bit, it looks like gobbledygook. It doesn't look like much, but you see that, can you kind of see that? That dog is right there. So that's what we're going to do. This kind of stuff, it's actually really can be used for lots of different reasons. Herzog and Demeron does lots of these Bendate dot patterns. And I mean, one thing I want to do before we go into Grasshopper proper is for your assignment 2, again, diagram of intent. If you were going to use image sampling for assignment 2, your diagram of intent might look something like this. You might say, I'm going to sample a image like this. I'm just going to draw this little checkerboard here so you can see I have black, I have gray, and then I have a sort of mid-gray. And then in your diagram of intent, of course, you would label it darkness relates to diameter of circle, but you could just draw this little arrow here and you would say black has a small circle. This kind of lighter gray has a large circle. The slightly darker gray has a mid-sized circle. And the white, which I will represent by this yellow, because, you know, white, is a large circle. And then maybe after that, I would say times 50. And then I'd put a little diagram of my image here pointing at that. So that's a diagram of intent. That kind of makes sense, what we want for that. I mean, try not to be as sketchy as this. I'm sure you all have wonderful graphic skills, so make use of those, but this is kind of it in a nutshell. So let's jump into Grasshopper proper. So the first thing we're gonna do here is we're gonna make a grid. So again, we've done this already. Essentially what we're gonna do is we are going to go into vector, grid, and then we're going to use square grid. So vector, grid, square grid. Now, if we highlight over square grid, you can see it says 2D grid with square cells. So if we go into the Rhino window, you can see that we have a grid with square cells. You can also see that we have this kind of fainter grid behind it. Does anyone want to guess what this fainter grid behind this grid represents? And let's look at the inputs of this component. I'll give you a hint. It's one of these inputs. It's the plane. So in Rhino, and we're going to be dealing with planes a little bit more in this class. So just to quickly explain a plane, in Rhino, when you're drawing in the top view, so you're drawing a plan, you're drawing in the XY plane, right? So if I'm drawing in the XY plane, I know that these curves are going to be flat to this plane. If you're drawing in, let's say, a front or side view, so an elevation and section, you can see here the little compass tells us we're drawing in the ZX plane. And if you look in 3D, you can see that we've drawn in the ZX plane. It's flat to that plane. And if we draw in the right view, we're drawing in, you see the little compass here, the ZY plane. So that's going to be perpendicular to things in the ZX plane. So when we talk about planes in Grasshopper, that's what we're talking about. We're just creating these drawing planes that you can draw two-dimensional images or shapes on. Later on, we'll make some cubes on planes. One thing to note is these are the three basic planes, XY, ZY, and YZ. Yeah, I didn't mix those up. But what can happen is you could have a plane. So in Rhino, for example, we can go C plane, set C plane by 3 points. And your plane could be at a weird angle like this, right? So now look at that plane. So you kind of have this plane that's on an angle. And now I can still draw on this plane. It's flat. But you see what happens. It's flat on that plane, but it's kind of at an angle to what we think of the general world space. So in Grasshopper, we're going to make use of the fact that we can kind of make planes in different angles to make certain geometries. So, and you see if I said back to our normal world plane, this object's kind of floating at an angle. So all that being said, this plane by default, if you hover over the plane input, it says world XY. So what that means is we're drawing a square grid on the XY plane. So that might have seemed kind of long-winded, but we're gonna use planes more coming up, and the explanation will sort of hold for all cases. The second input we see in this square grid component is the size of the grid cells. So you can see that these grid cells go from 0 to 1, 1 to 2, and then in the Y direction they do the same. They go from 0 to 1, 1 to 2, because they're squares. So that's all that means, size of grid cells. And then the extent Y, extent X, it just means how many squares you have in your little checkerboard here. So we have 5 this way, 5 this way. So that's what the inputs mean. Again, just to review, Grasshopper is unit agnostic. So I think my Rhino documents in millimeters. So whenever Grasshopper refers to the size, it's referring to millimeters. If this document was inches, Grasshopper would refer to inches. So Grasshopper doesn't care about units. Whatever your Rhino unit is, Grasshopper will do that. So we're going to use a few different sliders here. So can anyone remember the kind of the shortcut way of making a slider? Exactly. So to make a slider, kind of the quick way, we're going to double click on our canvas. And for size, let's just think about what we want for our size. So for size, we want, let's say, minimum 1. And also we're thinking of like a grid size. In this case, we can leave them as whole numbers. So if you want whole numbers like 1, 2, 3, 4, 5, 6, you can just leave it as 1. If you wanted floating point numbers, again, you could put 1.0, and that would give you an option to scroll through 1.1, 1.2, 1.3, etc., etc. But for this case, we're going to leave it 1, and then we're going to press the less than symbol. So that is Shift, comma on most keyboards, and we'll just say our maximum size is 10. And then press Enter, and that's going to make a number slider. It's worth sort of keeping things organized. So we can right click this slider where it says number slider, and we will call it cell size. We're going to do the same thing for extent X, extent Y. We're going to double click on the canvas. We're going to make a number slider by typing 1, so 1 in each extent, up to, let's say, 50. So 1 less than 50, enter. And we're going to use the number slider here. We're going to plug in both extent X and extent Y, simply because our little dog image here is a square, so we're keeping that in mind. So I'm going to take my number slider, drag it into extent X, and then I'm going to drag into extent Y. And then after that, I'm going to right click on my number slider, and I'm just going to call it grid extents. Is someone making pancakes?
Yeah.
Oh my goodness, it smells delicious.
Every Wednesday morning.
All right. So anyways, as we can see here, as we move this grid, the extents, the grid goes bigger. And now I'm just seeing this thing as a waffle now. But anyways, breakfast aside, we have our extents, we have our cell size. What I'm going to do is I'm just going to crank my grid extents up to 50, and I'm going to leave my cell size as 1, just so we have kind of a nice even number like this. Now, what we are going to do is we are going to use something called image sampler. So we're going to go to params, we're going to go to input, and we're going to go to image sampler. So params, input, image sampler. And now what we're going to do is we're going to put our points into the image sampler. So our points here, we're going to put it into the image sampler like so. Now, what I want to quickly review here is, before we jump into this, is just this dashed line versus the solid line. So as last class, as we know, we did data management, and it's kind of tough, but we'll just sort of review these topics as we go through them again. So what we see here in a dashed line, it means that there's more than one branch in this list, or as we think of it, more than one small box. So if we, for example, go to params, utilities, param viewer, and we plug, let's say, our grid extents into the param viewer, you can see what it says here: data with one branch, one item in the branch. And the one item is just this number 50. So essentially what this is going to look like, if we think about it, is our one box with a path 0. So you can see the path is right there. It has the number 0. And then within that, there's the value 50. So that's simple. If we look at the points here, so what I'm going to do is going to go params, utilities, param viewer again. You can see it says data with 51 branches, n equals 51. So what this means is that we have 51 small boxes. So you can see that we have a few leading zeros here. And what happens with how this works, just to review, is that any leading zeros or any leading number that is the same, it essentially is just an extra layer. So what's happening with 0, 0, 0, 0, 0, 1, 0, 0, 2, since these first two numbers are shared, what's happening is we have our first 0, it's holding everything, our second 0, it's holding everything, and then since we have 3 layers, like so, 0, 0, 0, but then on the third number, it actually starts going up, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. That is where we have our small boxes. And in each of those boxes, there are 51 items, so n equals 51. So there's two things we can do here. First of all, you can always get rid of leading zeros, and I do this a lot. I won't do it so much in this course, but if you do go into the advanced grasshopper course, or I'd say intermediate grasshopper course, you're going to find that I'm going to do this a lot. I'm going to right click my output here, and I'm going to go to simplify. And what simplify does is it just gets rid of all those extra boxes, right? And it makes it easier to conceive of. So now, instead of having these extra boxes, we literally just have 51 boxes with 51 items in them. So it's a little bit easier to think about. So instead of having box within a box, now we just have 51 boxes. Yeah.
So when would you go flatten instead of simplify your graph?
So that's a good question. So here we are going to flatten because we don't care about the order of these things. But does anyone want to hazard a guess why these things are even organized into different lists? So think about the numbers here. We have 51 branches with 51 items in each branch. What do you think this corresponds to? Because these aren't arbitrary. They always correspond to something in the geometry. Almost. Nope. So, and this is actually a really good example. This is sort of the most basic way you can see these data structures relating to the actual geometry. So if we look at our points here, what I'm going to do is I'm going to go params geometry point, and I'm going to plug my points into the point, and I'm going to do that just so we can actually see the points at those vertices, right? And then I'm going to use a component. I'm going to go to sets, tree, and then explode tree. So sets tree, explode tree. And you can see what tree does. It essentially just allows me to see what's in each branch. So let's plug our points into branch 0. And now you can see what happens. You can zoom in. So some components, when they have extra outputs, what you can do is you can zoom in and click minus or plus to add the extra outputs. But in this case, you can see here that right now I only have branch 0 showing. So that happens. It's showing me that these are the points in branch 0. So if I click this again, now I can see branch 1. You can see now I see all the points in branch 1. Branch 2, all the points in branch 2. So now do you guys again want to guess what these branches relate to? Exactly. So branches will relate to rows and columns. So that's an example of how data relates to actual geometry. This is more, I'd say, intermediate kind of grasshopper stuff. But if you are ever working on some sort of structural systems or, you know, all sorts of things, it's important to be aware of this so you can actually take advantage of the fact that these are rows. So with all that being said, what we're going to do now, I'm just going to delete the point and explode tree. We don't really need that right now. I'm going to right click and flatten this data. And now you can see what happens is that data with one branch, 2,601 points in this one branch. So now all the points we have there, they're no longer organized by rows. They're organized in one big clump. It's worth noting that the points, even though they are still in one branch, if you go to, let's say, display vector point list, so display vector point list, and plug our points into our point list, so points input, what you'll see if you zoom in, let's increase the size because that's tiny, let's increase it to 1. Whoa, that's huge. Okay, so rest assured, I'm not going to try to read that. Rest assured that the points still maintain, a certain order. So they're going to go from 0 to 51, then 52 to 103, then 104 to whatever plus 51. So they're still going to maintain that order, but they're not in a bunch of lists. Yeah.
Can you just go over how you got the data with branches?
Oh yeah, yeah. So that is params, utilities, param viewer. And again, param viewer, just a little visualization if you want to see it. You can always double click this and it's going to show you a graphic representation of how your data is organized. I personally don't find this super useful, but if you do, then just double click and you'll get that interesting looking chart.
Why is yours, mine is just like a circle with a
single line?
Yeah.
Because I unflattened just there, sorry. So I just unflattened. So now let's flatten again. So now mine is data with one branches. If I double click it, it's this, that represents the single branch. So now what we're gonna do is we're gonna use the image sampler. So I'm also gonna delete this other param viewer there. So image sampler, essentially what it does is it samples points coordinates and then uses those point coordinates to refer to an image. So let's double click the image sampler where this kind of exclamation mark is. And you can see that it opens this little dialog box called image sampler settings. And so the first thing we want to do is select a file path. So click the little dot, dot, dot right there and navigate to an image of your choice. Like I said, the sassy dog should be, you can also use the gradient if you want. It should be in the Dropbox. So I'm going to select this. And the other thing now is, so there's a few more settings. So the way this works is this is going to look at point coordinates, right? And you can see it's going to look at point coordinates from 0 to 1 and 0 to 1. And it's going to say, okay, what is the grayscale value at that point coordinate? And then it's going to give you a value between 0 and 1 relating to that, the darkness or lightness of the image. We will learn how to parameterize this a little bit more coming up. But for right now, what we're going to do is we're going to change our X domain and Y domain. So if we look at our square grid, we have a cell size of 1. And we have extents from 0 to 50. So we know that in the X direction, we go from 0 to 50. In the Y direction, we go from 0 to 50. So what we want to do is we want to change our X domain from 0 to 50. And our Y domain, we also want to change it to 0 to 50. So now when you see what's happening is the image is going to be sampled from 0 to 50. So and from 0 to 50. So for example, let's say there's a point at 25, 25, so somewhere in the middle there. It's going to sample a value of 1 because it's like pure white. In this corner here, let's say it's about 13 in the X direction, 25 in the Y direction. It's going to give us a value of 0 because it's black. So this is how this component works. Now, the tiling we won't worry about for now. One thing we do have to worry about though is the channel. So you can sample different channels from an image. So for example, you can sample RGBA colors, you can sample just red, just green, the alpha, so the transparency of an image, the color hue, the color saturation. So these are kind of interesting to use. I've used them a couple times, but for the most part, I find that you're going to be best served by using color brightness. So we are going to use color brightness. So we're going to click on the little white-black circle there. And then once our X domain and Y domain are 0 to 50, color brightness is selected, our file path is selected, we see a nice preview here. We're going to click OK. And now you can see this little dog appears on your canvas. So what we're going to do now is we're just going to take a look at the data that comes out. So a really useful component, and we've used it a little bit before, I'm going to use it for a different reason later this class, is the panel. So if you go to params input panel, you can see, you can write notes in it, which we'll do later, but for right now, we're just going to use it to see what data is coming out of here. So we're going to grab the output of our image sampler and we're going to put it into the panel. And you can see here are all the values that I was talking about. So we have values from 0 equals black, 1 equals white, and you can see that essentially what's happening. So the first point, I think, is the top left. So you can see that the top left, it's about a little bit less than a quarter gray. As it goes down, you can see it's getting a little bit darker as it goes down. So that's why these values are getting darker. And then somewhere in the middle, you can see that it really starts to get dark as it's sort of probably reaching in these areas, etc. So that's what's coming out of here. If you want for panels to sort of remind yourself of what these values mean, you can always right-click a panel and rename it. So just right-click where it says panel. In this case, we can call it B/W values. Like so.
How does this work when you're dealing with like multiple colors? Would it be like how close it is to a particular color? Or?
Yeah, so for example, so you don't have to follow along with this, but I'm just going to quickly switch this up. For example, if we switch to red, it's going to be a single value. If you switch to the RGBA, it's going to give you 3 values. Now, all these values are going to be the same because it's a grayscale image. But if you actually had a color image, it would be different. Also, I would say that here's a hint you could do for assignment 2 if you like image sampling. Try it with an RGB image, and then I'll just quickly say refer this video afterwards. You can break up the colors by going to display, color, and then split ARGB. So for example, what happens if we double click this, go to RGB, you can see now that we have an alpha output, a red output, a green output, a blue output. So maybe you're doing transformations based on this. So that would be an example of how you could use something we've done in class and use it for assignment 2. So I'm just going to delete that, and we're just going to keep on trucking along with black and white though for now. So now that we have these values, just going to make sure that, okay. So essentially what we want to do is we want to draw some circles. So the first thing we can do is we can just actually draw circles at these vertice points, so at all these corners of the grid. So to draw circles, we're simply going to go to curve, primitive, and then we are going to go to, we'll go to circle. So I noticed because again, in the notes that, because all of you guys in this intro grasshopper module have to cover the same material, but there's some things that you'll find are maybe different than some of your companions have done in other classes. They all do the same thing. It's just a matter of preference. So, but what we're gonna do is we're gonna take our points and plug them into plane. So we're gonna go points, we're gonna plug them into plane. So just to review, the circle is found in curve, primitive, circle. The input, it has 2 inputs. It has plane, so that's the base plane of the circle, aka the center point. Radius is the radius of the circle. And
What's the difference if you're at params, geometry, and then click circle there? What does that circle do compared to the circle that making?
Yeah, so good question. So this params tab, especially this geometry tab, and we haven't done a lot of this so far, we're going to do in the next example, is mainly to reference things from Rhino. So for example, if I go params geometry circle, it's going to be orange because it's not representing anything. So what you would do in this case is in Rhino, you'd draw a circle, you'd select it, you'd right click that component, and you'd go set one circle. And I guess that you have to go like this, which is kind of annoying. And then there you've referenced that circle. So the geometry or params geometry tab in params primitive is to reference Rhino objects mainly. And for the next example, we'll do something that references Rhino quite a bit more. So now you can see we have kind of this interesting tiled pattern. We have all these overlapping circles. So this is kind of interesting. Maybe you could make a neat drawing from this, but we want to vary the radii of our circles based on our image sampled values right here. So what we could do is honestly, we could just take these values and plug it straight into radius. So why don't we try doing that? So we can take our black and white values. We can either drag it from this panel. Panels are just sort of a, what would you call it? Like a throughway, like it won't change the data in the panel, or you can take it from this image sampler. I'll take it from the panel, but again, you could just go straight like that as well. So now you can see that what happens is we have our little dog there. It's quite abstracted. We still have lots of overlapping circles. And the reason why is because we're sort of giving a different radius. So we're sort of saying, the smallest is black, the biggest is white, but we're going between 0 and 1. So it doesn't really fit within our grid. So what we want to do to sort of correct this is to change this domain. So instead of going from 0 to 1, we want to go from maybe 0.1 to 0.5 or something. So we are going to remap the values. So we used this component briefly last class. So what we're going to do is we're going to go to math, domain, remap numbers. So math, domain, remap numbers. And just a quick review of what remapping numbers means, because it's something you'll use a lot, is it simply means that if you have a list going from 0, I always do that. That's a bad example. 1, 2, 3, 4, 5. And then you have another list going from, let's say, 3, 6, 9, 12, 15. If you have the number, let's say, 2, it is about 2/5 of the way through this list. So if you're going to remap this value to this list, you're going to look for something that's about 2/5 of the way through this list. So you're going to say that 6 is about 2/5 through this list. So that will remap to that. Likewise, if you have another number, like let's say you have 3.5, 3.5 is about 3.5/5 through this list, it's going to remap to the number that's between 9 and 12, right? So it's going to remap to 10.5. So that's what remapping does. So usually it's less about remapping numbers in like a series like that, but it's rather something like if you have a domain of 0 to 50, you want to remap it to a domain of 0 to 1. And let's say we want to remap the value 25. What will 25 remap to in 0 to 1? 0.5, yeah. So it's about halfway between 0 and 50. So it goes to halfway between 0 and 1. So that's what remapping does. So in the case of remapping this, what we want to do is we want to remap between 0 and 1 to a domain of our choosing. So what we're going to do is let's look at remap numbers. So if we highlight over where it says remap numbers, it just tells us what it does. First of all, it says remap numbers into a new numeric domain. The first input is value to remap. The value that we want to remap are these black and white values. So let's take these and plug them into value. So the second input is source domain. So by default, the source domain is 0 to 1. So that makes it easy for us here, because essentially what that means is that we can just leave this blank. What you might want to do if, let's say, you have a slightly different list of numbers, like let's say our numbers go from 0 to 10, you could either do two things. You could either use the domain construct domain component and define 0 to 10, or what you could do is you could go to maths domain bounds. So create a numeric domain which encompasses a list of numbers. So maths domain bounds. You could plug your values into the numbers, and now you can see if we hover over the domain output, we get 0 to 1. So it tells us the domain of these numbers. It gives us the smallest value in this list and the largest value of this list. So now we can plug this component into source. So you don't have to do this in this case, but that's how you do it if you have a different list of values. Finally, we have our target domain. So by default, it goes to 0 to 1 again. That's not remapping in this case. So what we want to do is we want to define a new domain. So let's go to maths domain construct domain. So maths domain construct domain. We'll put on the canvas. hover over construct domain. So it says create a numeric domain from two numeric extremes. So in other words, it's going to make a domain starting from our domain start input, and it'll end at our domain end input. And then our output is domain. So you can see here by default it's 0 to 1. And we're going to plug this domain output into our target input. And then what we are going to do is we're going to create two sliders to sort of be able to shift around our domain start and domain end. So shortcut to make a slider again is double click. Now, because we're dealing with a grid of a size of about 1, we probably want to deal with floating point numbers, so decimal numbers like 0.1, 0.2, etc., etc. How do we make sure that our numbers are floating point when we're making a slider like this?
Just include decimals when you type them.
Exactly. So in this case, our first value is going to be 0 point, and then you can choose how many floating point values you want. So if you just want, let's say you're working in centimeters, then probably you're going to want your decimal points to be like 1 millimeter. So you'd put 0.0. In an abstract case like this, we can just put 0.00, have two floating places, and then shift comma to get the less than sign. And then the domain end, we'll put it at something wild like 5.00. And then we're going to put enter. And then another little shortcut that I would do, if I was doing this, I would right click the number slider to change its name. So I right clicked where it said number slider, and then I will write domain. And then what I'd do is I'd just go Control C, Control V. So when I go Control C, Control V, it just copies it. You could also go edit, copy, edit, paste if you want, but Control C, Control V is fast. And then I could just right click the top one and add a start to the end of this. And then I could right click the bottom one and add an end to this one, just so we're organized and know what we're actually referring to. So let's plug the domain start slider into domain start, and the domain end slider into domain end. So now you can see if our domain start and end are both at 0, our domain is, 0 to 0, and our mapped values are all zeros. And if we plug this into our radius, so what we're going to do is we're going to take our remapped numbers output mapped, and we're going to plug this into our radius input of our circle component. So mapped will go into radius, and with a domain of 0 to 0, we're not going to see anything. But now if we start to increase this one, you can see now we start to see our dog. And if we put it all the way up there, we start to get this kind of weird little, overlapping image. We can also increase the domain start, and that's going to increase sort of our baseline condition there. So that is how we do that. I have a question for you. It's going a little bit off script, but it's kind of like just more this algorithmic thinking kind of question rather than knowing what component to use in Grasshopper. If I wanted to invert the size of these circles so that the dark areas here correspond to larger circles and the lighter areas here correspond to smaller circles, because right now it's the inverse and it looks like the dog is like a black bulldog wearing a diaper rather than like this lighter colored bulldog sitting in a swing. How could I do this just using the number values, let's say? So these values, our black and white values, go from 0 to 1. How could we invert that?
Your domain start higher than your domain end.
Maybe it'd work. I don't know. We can do something simpler than that though.
I just did it.
Should you use the negative operator in
Close, so close. So you could subtract all these values from 1. So think about it. If we have a value of 0, 1 minus 0 equals 1. So that's the inverse. 0 goes to 1. If we have a value of 0.25 in this list, 1 minus 0.25 goes to 0.75. So it flips, right? 1 minus 0.5 is still 0.5, so the midpoint still remains the same. So let's try doing this. So if we want to invert these circle sizes, and I mean, you probably could just double click on this and I think, oh no, there used to be an invert button, not anymore. But anyways, so what we're gonna do
I think it's in the tile.
in the,
You just see there's a tile option and you click, you select that. Is that
nope, no. So we'll just do it this mathematical way. So simply what we'll do is we'll go to maths, operators, subtraction. So maths, operators, subtraction. We're gonna, subtraction, mathematical subtraction. So simply A minus B. What we'll do is we'll go to params, primitive, integer. So params, primitive, integer. And what I'm going to do is I'm going to right click this integer component. You see right here, it's orange, it has no value in it. First, I'm gonna right click it. I'm gonna rename it to 1. Now, one very important distinction, when I rename this integer, it doesn't put 1 in this, right? It's just named 1. So I could call this thing Frank, and that's fine. So the name of something doesn't relate to what it actually holds. But the reason why I am naming it 1 is just so when I quickly go back and look at this definition, I know that this is 1. The way we set the number is we click on, so we right click it again, we go to set integer. So right click it, set integer. We'll click 1 or type 1. And then we'll click commit changes. So now you see it's turned gray. It means it has a value in it. If we hover over the output, it says 1 locally defined value, 1. So we can plug that into A. We can plug our black and white values into B. And now what we need to do is everywhere that we had our panel plugged into, we're just going to replace it with the result here. So I'm going to take the result of my subtraction, plug it into bounds. So you see it replaces that wire. And then I'm going to take the result of my subtraction and I'm going to plug into my remap numbers value input. And now you can see it inverts the circles. So that kind of thinking in Grasshopper, and I'll just sort of zoom in on this for a second if anyone wants to sort of rebuild it. So this kind of algorithmic thinking, when we say algorithmic thinking, this is what we mean. We don't mean knowing all the Grasshopper commands. We mean if you were to tell a robot who lacks all nuance, all context, any understanding of kind of subtext or whatever, how to do something. If you were to say step by step by step by step, this is how you do this thing, that is algorithmic thinking. This also relates to your diagram of intent, right? So the diagram of intent is literally a diagram of that step by step by step process. So for example, your diagram of intent, if you wanted to you've made this diagram to talk about how you're varying the circles based on the image sample. If you were going to diagram your intent for flipping the values afterwards, you could simply do a diagram that says black goes to white, 0 goes to 1, and then to flip, you would just say black goes to white, 1 goes to 0. Something like that, right? So that's what, again, an example of how you could diagram this thinking. It's not the actual components themselves. So do not do a screenshot of this for your diagram of intent. Do something that explains what your thought process behind it is. Very quickly, we're gonna use a gradient. I'll warn you that your computer, it might take a few minutes to think. So we're gonna sort of tread on this gingerly, but it's in this example and might as well use colors, I guess. We might do it a little bit different so it goes faster. Again, I'll save Tina's example so you can see how she's doing it. The main difference between what Tina's done and go into here, remember, if you need to find out where a component is, you can always hold Control-Alt and click it, and it's going to show you exactly where that component is. So if you want to rebuild this definition, the reason why I'm not going to use this one is because it runs a little bit slower. The advantage to going this route is that you can bake this geometry back into Rhino. So remember, to bake, we just right-click a component, click Bake, click OK, and now even when we close Grasshopper, you know, we have our sassy dog in Grasshopper. And actually, when the colors are inverted, you really can see this dog. So look at that.
Sorry, what did you bake there? The circles?
Yeah, so when you're baking something in Grasshopper, essentially anything you highlight over, so whatever turns green and you right click, that's what you're going to bake. So in this case, I baked the circles. So to color this though, what we're going to do is we're going to take these circles and we're going to make them into surfaces. So we're going to go to surface, we're going to go freeform, boundary surfaces. So surface, freeform, boundary surfaces. Now hover over boundary surfaces, create planar surface from a collection of boundary edge curves. We're going to plug our circle into the edges input. It's going to take a while because we have 2,600 circles.
Question.
Yeah.
You said Control-Alt to show where the commands are. Is it the Mac version? What the key that?
Command-Alt, maybe? Try it. Could you try it and confirm? Could someone try Command-Alt on Mac?
I don't know.
My computer right now. Option Command.
Thanks.
Okay, so now you can see what happened there is now we have all these surfaces. Your computer maybe solved before mine. Maybe it's still solving. But one thing to know is in Grasshopper, when you're doing like 2,600 surfaces, sometimes it will take a while. It's worth noting that like in actual professional practice, for example, earlier this year, we were doing a bunch of custom solar analyses, and we'd literally just have a toggle switch in Grasshopper and it'd be like run, and then we'd leave that computer for about a day and a half. So sometimes it takes a while. So with these surfaces though, what we're gonna do is we're now going to show them in colors. So we're gonna go to params, input, gradient. So params, input, gradient. And this is kind of a fun component. You can see that essentially it's a gradient. It has the lower limit, the upper limit. So this is the domain. In this case, it's 0 to 1. We're just going to leave it as default because we know that our bounds are, if we hover over our bounds component, are 0 to 1. And then the parameter is essentially the value. So in this case, our value is the result of our subtraction. So what we're going to do is we're going to take this result and we're going to plug it into the parameter input. Like,
I didn't have to do that whole results kind of thing. Like I didn't have to inverse my image at all.
Yeah.
I don't know. If you want to inverse it, then that's still how you do it.
Like we just changed the domain start and end value, it automatically did it.
Yeah, I mean, you can do that. So for example, in this diagram of intent, essentially that's what I'm doing, right? So, because this is just finding a position between your domains. So there is a difference between 0 to 1 and 1 to 0. So if you think of 0.25, between 0 and 1, it is about 1/4 of the way through the domain 0 to 1, but it's about 3/4 of the way through the domain 1 to 0. So therefore, in the first case, it relates to a 25% gray, and in the other case, it relates to a 75% gray. The reason why I use the subtraction rather than just inverting the domain is that it's just easier for me to conceptualize that in my brain. It's just simply a preference. So if for you it's just like makes more sense to just invert the domain, you can do that. For me, it makes sense to subtract and keep the domain the same, if that makes sense. So again, that's that algorithmic thinking. It's however you can figure it out in your own brain. There's lots of different ways to do things. In Grasshopper, as long as, again, you stay organized in your work, you'll find that you might do things totally different than me if you keep using Grasshopper for a while and start to really develop your own style, as it were. For this though, so I plugged my parameters into the gradient sampler.
So wait, where would we plug in then if we don't have the subtraction?
If you don't have the subtraction, you would just take your black and white values and plug into parameter. And then that is going to go into parameter there. In this component, if you double click, you can add more color dots. But what I like doing is just right clicking on the little rainbow swatch here and going to presets, and there's some interesting presets. So this is kind of like the usual solar radiation color scheme. Really, you can try whatever looks interesting to you. I'll do this one. You can slide it around, double click to edit a little bit more. I mean, feel free to explore this. We won't go through all the options here. So the last thing we're going to do, just to sort of color this bulldog, is we're going to go to display, preview, and then we're going to go to custom preview. So display, preview, custom preview. We're going to plug these colors into material, and we're going to plug these surfaces into geometry. And now you can see that not only are our values represented by the circles, but they're also represented by this gradient here. Now, right now it looks kind of abstract because we have both things going on, but if we want to, for example, change our domain from right now it's 0 to 0.6, if we change our domain start to 1 and our domain end, and it's thinking, we also change it to 1, then what you'll see is the colors will sort of be the defining factor in representing this image.
How is it knowing what to color?
Okay, so this is another data management thing. So, and it's saying, so essentially, remember that in those groups of lines, I can just click this. In those groups of lines, when we have an equal amount of dots, so like we kind of stumbled through last class, we have an equal amount of dots. What's going to happen when you try to draw lines between them is we're going to draw straight lines, right? If you have an unequal amount of dots, so let's say we have 2 more here, what's going to happen is you're going to start getting some strange things at the end, right? Likewise with colors, if you have let's say 20 colors and 4 objects, Grasshopper is not going to know what to do. It's just going to assign whatever color to whatever object, and it's not going to look like what you're expecting.
Right.
However, in this, since we've taken our colors are based on our black and white sampling, if we hover over our material input, you can see it says 2,601 values, so 2,601 colors. And if we hover over our geometry input, it says 2,601 values. They're all those circle surfaces. Grasshopper knows, okay, there's 2,600 of each. We're matching 1-to-1, like drawing straight lines between matched dots. So that's how that works. Let's say, for example, you don't have to follow along with this. We did something to get rid of half of the colors in here. So we went to sets, list, partition list. No, that's going to crash my computer. We're going to go to sets, list, split list is what I wanted. I'm just saying the index, don't worry about this, just an example. So essentially what I've done is I've gotten rid of about half of these colors. If I plug this into material, you'll see that it is matching half of the image, and at the end, we're getting a condition like this, where it's matching, 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 but since we have more circles than we have colors, it's just going with the last color it was able to find. So that is how to make a rainbow bulldog. So remember, when you're writing your AIBC exam, this will for sure be on that. I'm joking. But this is actually, you can imagine, for example, instead of this lovely dog here, you actually have an image of the irradiation of a facade on a building. All of a sudden, you can start changing the size of windows in relation to the sun. So what I'm going to do is I am going to delete all this, but I'm going to save this one right here. So this is the one that Thina had made, and it is more or less the same with one exception. The one exception is at the end, instead of making surfaces, she's made meshes and then applied the color to them. And the reason why she's done that is with meshes, you can bake a colored mesh. So what we did right there, even though we could see it on our screen, you're unable to bake the colors into Rhino. If you want to bake those colors into Rhino, then you would use a mesh like this. So I'll leave this to you to sort of explore and look at. So that'll be a good way if you want to do color geometry for your assignment 2 and you integrate this into what we covered in class. That's a way you can do assignment 2. So there's kind of one route you could take. It's modifying what we do in class, and that's why it's sort of diverged.
What step does she like deviate from this?
At the very end. So at the very end, we have our circles, we have our boundary surfaces, we have our gradient, but instead of using display, preview, create material, she's using a component called mesh colors. And the reason why I didn't do that in class is, as you'll find, it takes a little bit longer to solve, and I didn't want to wait here for 2 or 3 minutes. It's worth noting, and actually I'll even write a little note for you. So here's an example where you can use a panel. Go to params input panel. You can just double click panels to write notes. So in this case, I'm writing the note, make sure both inputs of mesh colors are grafted. So again, grafted, it just means right clicking and go to graft for both inputs. So that is why. And for the sake of time, I'm not going to get into why, but if you're really interested in why that's the case, send me an email. So I'm going to save this into the class files. So again, for assignment 2, you can't just take this and hand it in. But if you incorporate this into what we did in class, that's a perfectly acceptable assignment 2. Okay, so class files, image sampler, so here. So does anyone have any questions before we move on to a brick wall? All right.
Kind of have a general one.
Yeah.
When you like exit out of Grasshopper, you save it and stuff.
Yeah.
Does it how does the saving of the Rhino file work?
Oh, that's so the question was, if you save a Grasshopper file, how does the saving of the Rhino file work? And that's an actually extremely good question, and I'm sorry for not touching on that in the very first class. Saving a Grasshopper file will not save your baked geometry in the Rhino file. You need to save both the Rhino file and the Grasshopper file. That being said, if you're working on a Grasshopper file, a lot of the times I'll be working in Grasshopper. The Rhino file doesn't really matter. Like, for example, what I prepared for class here, I saved the Grasshopper file. I didn't save the Rhino file because I didn't really need the Rhino file, right? The Grasshopper file contains all the work. So, again, what I've done in this, I'm going to do a similar thing where this file here, so this stuff in the top, and I'll talk about grouping a little bit in this demo, is Tina's work. Again, I'm doing things slightly different. Again, if you look into the difference of what we do in class here, in this one, perhaps this could also be a springboard for your assignment too. I'm just doing this a different way because it's something that I feel more comfortable with. And I find sometimes if I go through other people's work step by step, I have to refer back rather than I just kind of do this stuff naturally. So that's why there's the difference, but I will save Tina's file, but refer to the video for my file. So we're going to do the brick wall. Sorry, so I'm just going to turn this back on because I did write some notes. So essentially, like I said, or I showed earlier in the class, we had the wavy brick wall, we had kind of a rotated brick wall. So what I want to do is I want to be able to take a curve, so it could be a straight line, it could be a spline like this, and I want to be able to array bricks around in the classic kind of staggered brick pattern. So that's what we're going to do here. If we have time, we'll work on applying an image sampler to rotate bricks. If we don't have time, then applying the image sampler, you'll find in the example file, and you can dig into that, and perhaps that's what you do for assignment 2. But what we're going to do is we're going to just start out by defining some things we want for our bricks. So before we do anything in Rhino, we're going to define 3 variables. So these variables are going to be the size of our bricks. Yeah.
Have you uploaded this script, or are we just making?
So we're starting from nothing right now. I will save this script here afterwards. But yeah, we're going to do it from a blank canvas. So essentially what we want to do is we want to define 3 variables, like I said, the length, the width, and the height of our bricks. So to do this, we're going to use our favorite thing in the world, number sliders. So we're going to double click to make a number slider. So for the length of the brick, we're working millimeters. I don't know. We're just going to make an arbitrary size. We'll say we have a minimum length of 1.00. Type shift comma less than a maximum length of, let's say, 10.00. Hit enter. I'm going to right click this number slider, and I'm going to call this brick length. And I mean, what I'm going to do now is I'm just going to copy this twice and then rename it. So I'm going to go Control C, Control V, and Control C, Control V. I'm going to right click the second one. I'm going to call it brick width. I'm going to right click the third input and I will call it brick height, like so. So now you can see we can sort of adjust the dimensions of the brick. Probably to start out, why don't we make the length for, I'm just thinking of, I don't know, dimensions for a brick. The width is going to be 2 and the height is going to be, we'll leave it at 1. They're going to be tiny little bricks, but that's okay. We can zoom in. So one thing you can do in Grasshopper, for my own personal work, I try to keep things very organized, especially if other people are going to be using something I make. So there's a few things you can do. First of all, if you have all these components like this and you select them, you're going to see that there are these little icons that appear. And for some reason, they're called Mr. Sparkle. So if you hover over this, it says align, and then it says Mr. Sparkle beneath. Not sure why. But what that's going to do is it's going to center them all. We're not going to use that one. We're going to use these little, the 3 or 4 lines, and we're going to use this to align them. I think that arrays, if you click the little left one, it makes them all equal. And then I think if you click, no, not that one. Yeah, so you click the top one and it's going to distribute them evenly. So just hover over and it'll tell you what it does. So the top one here, distribute objects vertically, distribute objects horizontally, align to that edge. So just a heads up that that's what you can do. So for example, if I want them a little bit tighter, I would click distribute vertically and then I'd align the left side. So the other thing you're going to do to stay organized in Grasshopper is you're going to group and label things. So you can now select all 3 of these sliders. You can right click outside of them and you can click group. And now you can see they're grouped. So now when we move them around, they're grouped together. And this is just a nice way to do it. Note that if you click an actual component within this group, you can still move them around. It's just they remain grouped like so. So I'll go like that. With groups, you can name groups. So this is very useful. So right click on the group itself, and I'm going to call this brick dimensions. If you want to, you can also change the colors of your groups. So right click the group and you can go color and then change it to whatever you want. Sometimes this is useful for if I have very, very large files in Grasshoppers. I'll, for example, color all inputs for, let's say, structural steel red. That's just like my default steel color for some reason. Wood in Grasshopper, for me at least, will always be yellow if I'm dealing like the project I'm working on right now. So that's why you might want to color those. For handing in your files for assignment 2 and assignment 3, for assignment 2, I'm going to give you kind of a, since we're still learning Grasshopper, I'm not really going to mark very much at all on how well organized your work is. For assignment 3, and for personal development and like just building up good habits, from here on out, please just try to keep your stuff organized. So as I go through, I'm going to be a little bit more conscious of doing that. So in your own work, please group, label with panels, all these sorts of things. So I'll just kind of set good examples as we go along. So just be mindful of that. Essentially, it's going to help you in a long time, in the long run. What we want to do is now we have our brick dimensions. The other thing we want to do is we want to reference our line that we're going to array a brick wall across. So I'm just going to click the little polyline component here. You could also in your window just type line to draw a straight line. And I'm just going to draw a straight line along the x-axis. It doesn't matter if you draw on the y-axis or whatnot for this example. one thing I'm going to do is I am going to look at the length of this line. So what I want to do is first I want to reference this line. So to reference something again, you go to params, geometry, and I'm going to choose curve. So we could choose line, but I'm going to choose curve because it's going to be a little bit more flexible. So params, geometry, curve. I'll put it on the canvas. I'll select the Rhino object. Then I'll right click the curve component and I'll go set one curve. Then I'll right click it again and I'll rename it, let's call it wall plan. So now we have this curve referenced, and you can see that it's referenced because when I select this component, this line turns green. What I'm going to do is I'm going to measure the length of this curve just to give us an idea of how many bricks we're going to have, because already I'm actually kind of thinking that I've made my bricks too small or my line too big. So what I'm going to do is I'm going to go to curve, analysis, length. So that's curve, analysis, length. And you can see here it says measure the length of a curve. I'm going to plug that, or I'm going to put that on the canvas, and then I'm going to plug my wall plan component into my curve input. Then I'm going to use a certain special component we've used before to sort of read the output. Does anyone want to guess what component we're going to use? Panel. So panel is a great component. So to use a panel, params input panel, or from here on out, because we're going to use panels a lot, I'm just going to double click and write panel. So you double click and write panel. So that's kind of the quicker way of doing it. And we're just going to plug this length into the panel. For our own organization, we can right click the panel and rename it input curve length. And we're just using this to kind of see what's going on here. And what I mean by that is that, for example, our brick length is 4. In reality, you know, you're going to have a brick wall with hundreds of bricks in it. But for this example, if our length is 4, our curve length is 366, it means we're going to have a lot of bricks. So what I'm going to do simply is in my Rhino window, I'm just going to make my curve smaller, just so it's a little bit more manageable for this example. So in the way I did that, just to refresh in Rhino, is I just made sure that gumball was turned on there. So when gumball's turned on, you have this little gumball cursor, and then I just dragged one end to make it smaller. So that's all I'm doing there. So now when we look at the length, it's 60. 60 divided by 4 is 15 bricks-ish. So, you know, this is a little bit more manageable, and this is what we're going to do. So from here, now we're going to start dividing this curve to start laying out that brick pattern. So now we are going to use a component called divide distance. So we're going to go to curve, analysis, actually no we're not, curve, division, divide distance. So curve, division, divide distance. Now, one thing I want to point out, also under curve division, there's another component here called divide length. So divide length is divide a curve into segments with a preset length. Divide distance is divide a curve with a preset distance between points. Does anyone know why we might choose divide by distance versus divide by length if we want a flexible definition? So a brick that can wrap both around straight lines and curved lines.
You could change the points, and that would change whenever you divide them.
Kind of. I'll show you why. So it's essentially what's going to happen here is if we go divide by length in a straight line, it's going to give us something like this, right? It's going to give us a length of L, a length of L, a length of L. And then our little bricks are great. They have a length of L, a length of L, a length of L. So divide by length works perfect for that. However, if we now have a curve like this, if we divide by length, we're going to have a length of L, a length of L, a length of L, a length of L, lengths of L. When we array our bricks on this curved curve, what's going to happen is at points like this, the length of the brick is not actually going to be the proper length, right? It's going to get smushed around these corners. So what divide by distance does is in a straight line, it does the exact same thing, right? Because it's still the distance from this point to this point is L. However, around a curved curve, instead of measuring the length along the curve, it's going to measure the distance. So it's going to say, there's a distance of L, there's a distance of L. It's going to go, there's a difference of L. So it's going to square off that corner, which works better for bricks. So just a small thing. A lot of times in Grasshopper, it's little things like that that might make your definition work a little bit differently than expected. So just to keep in mind why we went one way instead of the other way. So with that being said, the curve we want to divide, so the first input into divide distance is curve to divide. Let's put our wall plan into the curve. And now our distance is going to be our brick length. So we're going to take our brick length slider and plug it into distance. And now you can see we have a nice little divided curve here. It's worth noting that you can see it's divided, but there's a little bit left over. And that's simply because if we look at our input curve length, it's 60.27 divided by 4 equals 15 and a little bit. What you can do is you could either make this curve a multiple of 4, or else you could just live with having a little bit there at the end. There's lots of different ways to sort of solve this problem. We won't get into it right now. We'll just be fine with having this little bit on the end. It doesn't really matter to us. So what we're going to do, just referring to my notes, is it says also mention. Yes, I know what that is. So what we're going to do now is we are going to divide this curve. So this curve has points on it, but it's not a bunch of different curves, if that makes sense. So there's points on this curve, but the curve itself is not split up. So to take these points, we are going to go to curve, division, shatter. So curve, division, shatter a curve into segments. We're going to plug our curve into the curve input in shatter. And then you can see in the divide distance, there's something called parameters. We're going to take these parameters and plug them into the parameters input. And now you can see what it does is it says 16 locally defined values. And if you were to count the segments here, 1, 2, 3, 4, 5, all the way to this little chunk left at the end, you'd have 16 segments. So that's what that does. Now, I want to talk about parameters for a second. A parameter on a curve is essentially a local coordinate system to a curve. So what I mean by that is if we look at our parameters here, so if I'm just hovering over the parameters output, my curve has parameters going from 0 to 364. Yours is probably going to be different. Actually, it'd be very strange if somehow you drew the exact same line as me. So yours is going to be something different. And essentially when Rhino draws a curve, it's going to assign a curve its own parameter, right? So a straight line can have a parameter from 0 to, in my case, 364. And the reason why Rhino assigned this parameter is when I originally drew this line, remember how I'd drawn the line very large and I'd shrunk it? Essentially, Rhino said, okay, it was a curve from 0 to 364. Those are the parameters. So if I think about how I'm going to, in my computer brain, think about this curve, I'm going to think about it from having 0 point here, 364 point here, you know, about 175 or 180, whatever in the middle. And even if I shrink that, it's still going to maintain those same parameters. That doesn't change. So it's a localized coordinate system that is different from the overall XY system. A lot of the times that's kind of clunky to think about, right? Computers know how to do that. For humans to keep track of all the parameters along the line, it just doesn't make sense. So what you are going to do 99% of the time when you reference a curve into Grasshopper is you're going to right-click it and you're going to go to reparameterize. So right-click and go to reparameterize. And now if we hover over our parameters here, you can see that it goes from 0 to 1. So the division points are 0 to 1. So what reparameterize does, it's like remapping for a curve. So this curve goes from 0 to 364 to being 0 to 1. It doesn't matter the length, it's 0 to 1. If you need to find the midpoint of this curve, it's 0.5. Find 1/4 is 0.25. This also works for squiggly curves. So for example, a curve in Rhino like this, its parameters might be 0 to, who knows, like 74.2, whatever. If you reparameterize this, it'll go from 0 to 1. So that's all I'm doing there. So just keep that in mind. Reparameterize 0 to 1. We might not need to do that, but it's usually just kind of good practice to do so. So now what we're going to do is we have all these shattered segments. We want to find the midpoint of each of these segments because we're going to use that to draw a plane. So remember in the beginning of class when we talked about planes, we're going to make a plane local to the center of each curve, and then we're going to use that plane to draw our brick, so our three-dimensional object. So let's go to curve analysis, horizontal frame. So get a horizontally aligned frame along a curve at a specified parameter. So curve analysis, horizontal frame. We're going to plug our segments into the curve. And then our parameter, thinking that, you know, about curve parameterization, if we want in the center of the curve, what should our parameter be? 0.5. So to do this, we can, you know, go to params, primitive, number. We don't want integer because we need a floating point number. So params, primitive, number. We're going to right click this number. We're going to call it, so name it 0.5, just so we can quickly review. And then we're going to go to set number 0.5. And if you've done that correctly, this component will turn gray. And if you hover over it, it'll say output 0.5. And we're going to plug that 0.5 into parameter. Now, here's another strange thing. We only see one plane, and it's in the center of our bigger curve. Can anyone think of why that might happen?
Because you parameterized it to 0 to 1.
Yeah,
All of that?
exactly. So it's kind of strange because here's what Grasshopper's thinking. It's saying, okay, you have this curve. It's parameterized from 0 to 1. You split it up, and you told me to put a frame at 0.5 on each of these curves. Even though we divided this curve into smaller curves, we didn't assign new parameters to the smaller curves. So they still have the same coordinate system as the big curve. So even though, kind of counterintuitively enough, this curve right here, it still has a domain of 0 to 1 out here. So to find the midpoint of this curve, it's actually going to be closer to something like 0.9 or something, whereas the midpoint of this curve here might be something more like 0.1. So does anyone know what we can do to these curves to get the midpoint then? We can, again, just reparameterize. So again, we're just going to right-click curve and click reparameterize. So right-click the curve input of horizontal frames, reparameterize, and now you can see that we have all the frames in these curved segments. Now, at this point, what I want to point out is why we're using these horizontal frames and not just choosing like the center point of the curve. The reason why we're using these horizontal frames is that in a straight line, you know, it's like whatever, they're just kind of arrayed along this line. But now let's go into Rhino and let's use the control point curve tool and draw kind of a, I'm going to say moderately wavy line like this. And now instead of our straight line, let's go back into our grasshopper definition and go to our wall plan input. Let's right click wall plan or your curve input and go set one curve. You can see what happened is these horizontal frames are aligned with our curved curve, our wavy curve. So that's why we're using the horizontal frame component here, is because we want to align these bricks with the curve. And that's sort of the magic that allows this to happen. You can keep this curved curve referenced. I'm just for sake of showing how this definition works, I'm going to select my straight line again. I'm going to right click my wall plan component and I'm going to go set one curve. And that is going to switch back to my straight line there. So any questions up to this point? Yes.
Is a frame a curve or like a vector or what?
A frame is a plane. Yeah, so whenever you hear the word, so it's kind of, there's some synonyms in Grasshopper that more or less mean the same thing. So you'll hear C-planes, planes, and frames. They're all the same thing. So and then also I'll say that a plane is always, you're always going to tell something's a plane because it'll usually have this kind of ghosted grid type element in it. But even more so, it's going to have these two little axes. So it's going to have a red line and a green line, and that refers to its local X and Y axis. You can also see that as a little blue line here, that refers to its local Z axis.
How do you get the blue line to show?
I don't know, it just showed. It might be in display. You might want to preview plane size 8, preview settings.
Does it matter?
No, it doesn't really matter. But anyways, just go through your settings. I leave my settings as default, I thought, but but it doesn't matter. As long as you have the frame here, that's all good. So what we're going to do now is we're going to start drawing bricks. And to do so, we are going to draw the domain box. So again, I'm sort of deviating a little bit from this example I'll save in the Dropbox. Just go through it and see if you can parse out the differences and why someone might choose to do one thing versus the other. If you have any questions, email me. I'll be glad to answer your question. But we're going to use something called a domain box. And what a domain box does simply is if we have one of these localized frames, so each point has its own frame, which has a X value and a y value and a z value. And it each has its own little origin point, which is the center point of the lines we just divided. So if we're drawing a brick and we don't want to say it just has a width of, let's say, 4, because what that's going to do is it's going to draw a brick width from 0 to 4. It won't be centered, right? So what we want to say instead is if we want a brick with a width of 4, what domain do you think we'd say if we want it to be centered? Exactly. So we're going to say instead of 0 to 4, we'll say -2, dot right there, to 2. So that's a width of 4, but it's centered on 0. We're going to do the same in the y. So we're going to go, let's say, if we want a depth of 1, or a depth of 2, let's say, then we're going to go -1 to 1. Bricks, because we want to stack them from the ground, and usually in architecture and landscape architecture, we think about 0 as being the origin and elevation. We're going to change it up. For that, we're actually just going to go 0 to the height, because we don't want negative height to the height. So we're going to go 0 to height. So that's going to be the exception for the height. So to do that, we're going to go to surface, primitive, and then domain box. So surface, primitive, domain box. The base is going to be our frames here. So you can see the domain box, it asks for a base, so that's the localized plane, and then the domains in X, Y, Z like we just discussed. So let's plug our frame into the base input. You can see it's just making these little default bricks, whatever size it does by default. And now we need to make some domains to plug into X, Y, and Z. So X is going to be our brick length, so our dimension in the x-axis. So brick length means we want a domain of -2 to 2. So what we're going to do is we're going to go to maths, domain, construct domain. So again, maths, domain, construct domain. And can anyone think about what mathematical operation we could do to get -2 out of 4? You could use -6, but then what happens if we change the length to 8? Then it doesn't work. Yeah, so to do this, to center something, usually what you're going to do is just divide it by 2 and divide it by -2. So for the domain start, since we want it in the negative, we're going to plug our brick length into domain start. And let's actually plug into our domain end as well. So brick length, plug in domain start and domain end. You can see that the domain is 4 to 4. We want to change it to -2 to 2. What you can do in Grasshopper is you can apply very simple formulas to inputs. And it's just a nice way of sort of, working and being concise. So what we can do is we can right-click the domain start. And we can go to expression. In time to dust off your old algebra. We are going to use the little expression -x divided by 2. So when you're using the expression editor, you're always going to use the value x. So x means input. So for example, if we want to go 4 divided by 4, it would be x divided by 4. For this, we're going to go -x divided by 2. So if we think about what that does, it's doing -4 divided by 2 gives us -2. So once you have that expression in there, click commit changes. When you have an expression in your component, you're going to see this little asterisk symbol. And if you hover over it, it's going to tell you the expression. Again, we want to go to domain end. So right-click domain end, go to expression, and then what expression do we want for the domain end? x divided by 2, exactly. So to get negative 2 to 2, the domain end will just be x divided by 2. And now when we hover over our domain, you can see it's now negative 2 to 2. The nice thing about Grasshopper is you can, since we know we're going to use the same kind of logic for our brick width because we want to center it on these planes. What we're going to do is we're just going to take this component here that already has our nice little expressions in it. We're going to go Control C, Control V. And then what we're going to do is we're just going to take our brick width. We're going to plug it into domain start and domain end. And I will just move these up. And then finally for the brick height, since as we've talked about for the brick height, we don't want it to go from negative 0.5 to 0.5 because we want the bricks to start piling up on our world XY plane. We want it to go 0 to 1. So for that, we're just going to go to Maths, Domain, Construct Domain. Domain start by default is 0, so that's fine. Domain end, we're going to plug our brick height into domain end. So now that we have those domains, the top one is going to be our brick length, aka our x value. So plug our top construct domain into x in your domain box, your middle construct domain into your y, and your final construct domain into your z. And now you can see what happens as we move along these brick dimensions. You can see that they are sort of parametric now, right? So you can move them around and they'll adapt along this curve. If you make your bricks wider, it just means the curve length won't change. It'll just mean that you'll have more or less bricks. Now, there is this weird overlap on the end. Again, that comes from just the fact that there's a little bit left over on the curve. We'll leave that for now and we'll just live with it. If you really don't want to live with that for your assignment 2, email me and I'll tell you how we can start to think about getting rid of that final brick. I'll give you a hint. It's how we would call that final brick. But anyways, that is our first row of bricks. Okay, so we have enough time to for sure do the top row. So thinking about a staggered pattern, I'm just going to put my bricks so they fit fairly well. So we have this row of bricks. Each of these bricks is made on the center point of these divided lines. Can anyone think about how we could quickly make a staggered row of bricks?
So that it starts at 0 rather than -2?
Yeah, actually, you could do that. Yeah, you probably could do that. So that is not a wrong answer, but it's not what we're going to do. There's always so many ways to do it. What I am going to do, I guess is the better way to answer it, is we have these division points, right? And what we did was we divided these points with, or these curves with these division points. And then we found the midpoint of the shattered curves. I'm just going to take the division points that we divided the original curve with and use them as the basis of our new bricks. So you can see that they're on the edges of the bricks. So we can just take advantage of that fact and create a staggered pattern using these points. So what we're going to do is we're going to move these points up. We are going to actually, wait. Okay, what we're going to do first is we are going to make frames at these points. So another thing you can do in Grasshopper, if you have a lot of things previewed, is we don't really care about seeing these frames anymore. So what I'll do a lot of the times is I'll select a bunch of things with the exception of my most recent component. So you can see I've selected all the components here leading up to this one. and I'm going to right click outside of them, and I'm going to go preview off. And you can see that kind of clears up our display window here. We just see our most recent bricks, and that's kind of what we're going to go with. But what I'm going to do now is I'm going to make horizontal frames at my original division points. So we have our divide distance component here that was dividing the curve. I'm going to use these parameters on our original curve to create new horizontal frames. So what I'm going to do is I'm going to go to I'm going to go to curve. I'm going to go to analysis, and I'm going to go to horizontal frame. So curve, analysis, horizontal frame. The curve will be our original wall plan curve. So I'm going to plug the wall plan curve into the curve input of horizontal frame. And the parameter is going to be the parameter that comes out of our divide distance component here. Because remember, those are these points. They're the points at which we shattered this curve. So if I plug the parameters out of divide distance into the parameters input, you can see that we're already starting to see the staggering. So these frames are offset from the bricks we've drawn. So now I can draw bricks on these frames, but can anyone think about something else we might want to do before we start drawing bricks on these planes? Think
Add the
about,
mortar.
sorry?
Add the mortar.
Yeah, okay, so actually that technically the next step. So we've laid one row of bricks, we've added the mortar. Unless you're like a quantum bricklayer, you're not going to lay them in the same place. We need to move them up to the next row. So to move them up, we can go to transform, Euclidean, move. So that's transform, Euclidean, move. We are going to move the frames. So we're going to plug our frames into geometry. So now you can see the frames have moved up. The second input for move is the translation vector. So by default, it's moving it 10 units up. We want to base our movement up on the brick height. So what we're going to do is we're going to select the direction by going to vector, vector, unit Z. So vector, vector, unit Z. So unit Z again is straight up. We'll plug our unit vector into our motion input of move. So now you can see it's moving up by the default of 1 straight up. And then we're going to plug our brick height slider into the factor of unit Z. So this is defining the direction, and when we plug the brick height into the factor input, that is defining the amplitude of that vector.
This quick question, if
Yeah.
you wanted to add mortar, for example, could you make it, could you do like a thing like factor plus 0.25?
Yeah, exactly. You could do that. Absolutely. Anyways, now we have this. Essentially what we can do, and now it's kind of nice because we've already set up these domains since we know the bricks are going to be the same. Simply what we can do is we can take our domain box. So the thing defining our bricks right here, we can go Control C, Control V. So take your domain box, Control C, Control V. We've already defined the size of the bricks. Now all we need to do is from our move component, the geometry, aka the planes that have been shifted up, we need to take the geometry output and plug it into the base input of domain box. And now you can see we have our next row of bricks. So now if we preview off all of these things, you can see that now we have this kind of row of bricks. Okay, so I know class is technically in the end. So what I'm going to do is I'm quickly, so you can review it on the video, going to show you how to array these bricks up. And then what I will do, I will ask those of you who need to get going, I understand some of you have a class in like 10 minutes or something, to exit quietly. I'm going to continue for 8 or 9 minutes, just so I can do a few more things so you can review in the video. So if you do really need to go, I ask you to be extremely quiet. Remember, assignment 2 is due sometime tomorrow. I'm not going to be looking at the time you submit it, so just hand in whenever you can tomorrow, / maybe it's like super early AM Friday. But again, it's take something that's in the Dropbox or something we've done in class, modify it, make it a diagram of intent, hand in, email me if you have questions. But what I'm going to do now is I'm going to array up these bricks. And in fact, for those of you following along, I would suggest that you just sit back and relax, because I'm going to go a little bit quicker here, review the video. I just want to get through this stuff. So essentially what we're going to do is we're going to take these bricks and we are going to array them up. So in the same way you can do a linear array in Rhino, we are going to do a linear array in Grasshopper. To do that, we're going to go to Transform, Array, Linear Array. The geometry that we want to array are going to be our 2 rows of bricks. So we're going to plug in our blocks into geometry. To add another input into a single, or to add another output into a single input, what you're going to do is you're going to hold Shift, and then you're going to see this little green cursor with the plus symbol on top of it. And if you continue to hold Shift, you can drag it into the same input, and you'll see that that will allow you to plug 2 or more components into a single input. So hold Shift. If you ever want to remove something as well, you can always hold Control and drag like that, and it's going to remove it. But to add more than one thing, hold Shift. The direction, we need to define the direction and again the amplitude. So again, we want to move these up. So we're going to go to vector, vector, unit Z. The direction will be unit Z. And the amplitude, or the factor, will be our brick height times 2, because we're moving 2 rows, so it's twice the height. So what I'm going to do in my factor here is I'm going to right-click the factor input, right-click factor, expression, and then I'm going to go to x times 2. So multiplication, do not use, it's not xx2. When you're doing multiplication in most programming languages, it's the uppercase 8, so the little asterisk. So x asterisk 2, so x times 2. And now what you'll see is we get our brick wall. The final input for this is count, and by default it's 10. But what you can do is make another slider. I'm just going to double click. Because you can't have 0.5 rows of bricks, you can only have integers, so 1, 2, 3, 4, 5. What I'm going to do is I'm going to type 0 less than, I'll say 20. I'll hit enter, and I'll plug that into count. So that is going to allow us to adjust the height of our wall. Now, essentially what's going on here is we just have this simple brick wall. It's nice because it's parametric and everything. You can see that the width's adjustable, the length's adjustable. But the thing that I did that I think is kind of interesting is that since we use the horizontal frames, now if you, for instance, want to use this squiggly curve instead of the straight curve, you can just select another curve. So this is what I'd call a flexible or robust definition. So I can select this curve here. I can right-click the wall plan and go set one curve, and now you can see we have this rotated brick wall curve. So if you want to enlarge this in Rhino, so maybe I'll just take this in Gumball, drag it out like this, you can see it automatically updates. And this is really the power of Grasshopper, right? Is it allows you to say, okay, I want a brick wall. You don't want to model a brick wall like this in Rhino. You set up this definition in Grasshopper, and now you can change your plan and your wall's going to automatically update. So I think I will leave it there. What I am going to do is I am going to save this image sampler, kind of the file that Thina did. And I would challenge some of you to think about integrating this section of the definition into what we've done here. And that could also be a basis for assignment 2. Maybe this evening or in the next couple days, I can't promise I'll be able to do it before your assignment 2 is due, but I might record a little addendum to the end of this where we do more transformations. But I think that's pretty good for making a parametric brick wall. Does anyone have any questions before I end the recording? Yeah.
So would there be a way, I'm sure there's a long answer to this, but we have that shape of a wall now to complete it as like an arc going the opposite way to make like
A vaulted ceiling?
Yeah.
Yeah, there's always a way. You would start to work with a surface, and instead of a curve that you'd extrude up, you'd subdivide a surface. If you email me, also if you ever have a question like that, like how do I do a vaulted arc, for example, it's a little bit too long of a question for me to answer right now. It'd be another class. But if you email me, I will gladly send you the start of a definition or resources. So that's something I can send me an email, and I'll absolutely show you a couple steps. And I'll save in the Dropbox for everyone else as well. Yeah.
There are spaces as it moves around the curve.
Yes.
Is there a way to account for those spaces and lock them in so that it's flush, or?
So the question, it's things like this. So it's like the overlap and everything. So again, you have to think about your intent in this. So for example, if you were to be designing an actual wall and you're given an actual brick and you have a curve like this where you have weird intersections, there's a few things you could do. You could just, adjust these parameters. So that doesn't look good. That works. You'd actually probably adjust the width until you don't have intersections. And that would just be a constraint of the design, right? You might also chamfer the bricks, and that would be a different definition. So there absolutely is a way to do that. Again, send me an email. I'll show you how. But again, it's sort of out of the scope of, it would be, you'd have to start from somewhere else rather than using this method. Yeah.
Going back to the saving thing.
Yes.
In this case, we have things in a Rhino file that are basing off of Grasshopper, so we would say both Rhino.
Yeah, so let's say I'm working on this in Studio, and not only do I have my Grasshopper definition here, but I have my plan that I'm very happy with. What I would do is I would go save document as for my Grasshopper. I would usually, I don't know, however you label your stuff, I usually use the date like this. I would say brick wall definition, like so. Another thing worth noting is if you have a brick wall definition, just keep this definition and save it outside of your project, save in your Grasshopper scripts folder, because in a year from now, if you want a brick wall from a line, you have it. It works for anything, right? And then, so I've saved that, but now for the Rhino file, I would save as probably in the same folder. Maybe you've subdivided your folders. Another thing, 0122, brick wall plan. Now they're both saved. So that's how you do that. So like I said, I am going to delete this stuff here. So you have to watch the video. I'm sorry, but it's kind of, I found that if people remake stuff, they actually learn it. But that being said, I will save a different version of what we did in the class files folder, so you can sort of look at that. And like I said, try to work in perhaps the image sampler component of this into what we did in class. Other things for assignment 2, you might think about how to color the brick walls. So maybe you could do that. You might think about how to rotate the bricks within the brick wall. The other thing too is if you're working on assignment 2, send me an email I might, if I don't answer it tonight, I'll answer tomorrow morning. And then you can use whatever input I give you to work on assignment 2. So assignment 2 is just about experimenting with grasshoppers. So try to do something slightly different from what we did in class. So with all that being said, I will